are going to develop an ARM core processor for the development of an asynchronous process over the group, and we had to develop the test cases for working fully functionality working of the processor, and we have developed many test cases, like about 400 test cases to check the functionality of each and every instruction the processor has, and we came up with modifications on the core, so to improve the functionality of the core. For example, this verification. This instruction, this part of the instruction would verify the branch test cases. It moves from this point to this point, indicating there is a forward branch, and it moves back, indicating there is a backward branch. And when the test completes, it proves the functionality of the forward branch as well as a backward branch. So this is a typical branch testing mechanism, and this is a load store mechanism which is going to test, and we'll be loading memory continuously, and we'll be retrieving the values from the memory and seeing whether the values are correctly retrieved or not. So this is a typical load store testing mechanism, and we were able to come up with modifications on the core because some of the instructions have not been implemented, and finally we modified some of the instructions. Now the core functionality is up to 80% correct. So we had to, basically the bottom line is we had to come up with as many test cases as possible and modify the core to improve the functionality of the core, which has to be tested on an ML605 board, which is a FPGA board. So this is the bottom line.
Hi, this is our M.Eng project. So actually this is the board we are using. The board has an ARM 7 core, and it has a 64 megabyte SD-RAM, and it hosts a 64 gigabyte flash memory. So actually for the basic architecture of the board, the host gets read and write request from the board gets read and write request from the host, and an entry is included upon the request is received, and one entry is removed from the queue during the FTL. So every time one request is getting through the FTL layer and then go to the flash controller to issue the command to the real flash memory. So this is the original one. There is only one queue here, so that there is no scheduling. And what we have done is to enlarge the queue size to make it several entries in the queue, so that we can schedule it. We can make the issue out of order. So let's say in this scenario, what if we have successive commands to the same bank? So actually here we have the first command issue to A0. So bank A0 starts to be busy, and then we have another command issue to A0, and then the second command has to wait for the first one to finish, then the second one can issue. And then let's say we have a third command that issue to A3 bank. So this is the scenario for successive commands to same bank. But if we can reorder it, we can schedule it, we can put the A3 command ahead of the second A0 command, so that this is the performance we can get. Like the same scenario, but we can get this like a performance improvement. So basically we add a queue here to make the command issued out of order, so we can get some performance improvement. So this is what our project is basically